Today's program is being broadcast throughout North America, Western Europe, and portions of Latin America. We are still tabulating our total audience, but I can tell you now that our participation today will probably surpass our second symposium last June. More than 55,000 people at over 1,000 sites in 16 countries joined us for that one. We feel this says a great deal about the worldwide interest in artificial intelligence and its potential to increase productivity. We feel it also says a great deal about the need for this type of symposium. Why is Texas Instruments sponsoring these programs? Well, we have a large stake in AI. We have invested heavily in the technology and have a company-wide strategy to exploit its potential to increase productivity throughout our operations. Beyond that, we have a wide range of AI products and services to help our customers realize the early advantages offered by these new technologies and to be prepared for the timely application of future developments. So if you're ready to begin, we're ready to help. Our goal today, however, is to provide the kind of useful, unbiased information that can help you understand AI and put it to work. To that end, we have sought the independent viewpoints of some of the most knowledgeable experts in the field, and we have conducted direct interviews with people who are using artificial intelligence to solve their own problems in business, industry, education, and defense. In all cases, we have done our best to keep the information practical, up-to-date, and objective. The response from participants around the world has been overwhelmingly positive. It is this powerful response that has encouraged us to continue the series. Now I'd like to introduce the man who has done the most to help make this series possible, and in the process has made a major contribution to the development of knowledge about this important technology. A newly elected TI Fellow, an active member of the AI research community, and producer of the TI Satellite Symposium series on artificial intelligence, Dr. Harry Tennant.
This is our third AI symposium. What we've tried to do for you this time is to give you a sense of where the application of AI technology stands today, what's being done, what changes are being seen, and what to expect next. We spoke with people in major corporations and in small businesses. We talked about building knowledge-based systems and about organizing AI activity that can pop up voluntarily at many places throughout a corporation. We looked for major new trends and evidence for and against our currently held beliefs about what works and what doesn't. We also spoke with experts in the field to get their impressions. We interviewed James Martin, author of over 30 books on data processing and lecturer on the strategic significance of knowledge-based systems and exploratory programming, and Richard Gabriel, President and Chief Technical Officer of Lucid Incorporated, which markets AI system software. And as you know, we held a roundtable discussion with some of today's leading authorities on AI. So, what you're about to see is a combination of the experience of some successful users, the perspective of some key experts, and the opinions of some important contributors and appliers of the technology. In preparing this symposium, I've come to four main conclusions. First, many corporations are recognizing that knowledge-based systems will be of strategic significance because of pervasive opportunities for improving knowledge-based tasks. They see cost savings, improved quality, new avenues for revenue production, and opportunities for a competitive edge. In response, they're looking at corporate-wide approaches to bringing in and utilizing the technology. Second, some cost-effective applications of natural language technology are now in use: natural language interfaces and narrow domain text understanding. Companies stand ready right now to build natural language applications, and some toolkits are available. Third, one of the major benefits from AI research has little to do with AI directly. The programming environments and techniques developed for AI research can also be applied to conventional programs. In particular, the ability to do rapid prototyping, or what some refer to as exploratory development. This is being seen as a way to limit risk in large programming projects. Rapid prototyping is also valuable in helping customers to more fully define and articulate their needs at the beginning of projects. Finally, we're beginning to see what I think is a most telling sign for knowledge-based systems. They're ceasing to be just standalone applications. They're more commonly becoming integrated with the installed base of conventional computing, especially with databases and real-time applications. As knowledge-based systems become components embedded within larger systems, some of the glamour may disappear, but their usefulness will greatly increase. Now let's begin. The members of our roundtable are Herbert Schorr, Group Director, Products and Technology at IBM, responsible for the introduction of new advanced technology and applications into IBM. Douglas Lenat, Principal Scientist at the Microelectronics and Computer Technology Corporation, MCC, and widely recognized for his contributions to the field of knowledge-based systems. Ed Feigenbaum, Professor of Computer Science at Stanford University, founder of 2 AI companies, co-author of the 5th generation, and the person most responsible for bringing practical knowledge-based systems into the world. Roger Schank, Professor of Computer Science and Psychology at Yale University, recognized for contributions to natural language research, author of 11 books, and founder of an AI company. George Heilmeier, Senior Vice President and Chief Technical Officer of Texas Instruments, responsible for corporate research, development, and engineering. Alan Kay, Fellow at Apple Computer, and sometimes attributed with being the person most responsible for bringing the personal computer into being.
I think the strategic importance of this technology really can't be overstated. I mean, it will lead to, we may not have seen that yet, so I think the executives need to understand that. I think there are lots of courses of a half-day or one-day duration that you can take. Those are available, and I think management at least has got to get familiar with the concepts, at least to the extent of a couple of day courses, so that I think the expectations I think I have of this technology really is that we're going to begin to automate the front office applications. Up till now we've primarily done back office, by which I mean payroll and transactions of that sort, accounts receivable. Being able to help someone in the decision-making process is really a tremendous step forward, and the technology is ready. We're ready to do those sorts of applications. So I think we have to go through an education process, and it's different levels will be appropriate for different people in the hierarchy. I don't expect management to sit down in front of these tools and write an application for 3 months. They'll take those courses, and various levels of people will take the appropriate courses, and they are available. They're becoming available.
Where are the opportunities that have paid off? The opportunities that have succeeded have often been due to a good choice of task, a good choice of problem, which finesse the kind of sophisticated learning on the one hand, and make use of, that leverage existing systems on the other, existing hardware systems, existing software systems. So for example, many of us have come up against some huge existing piece of software that everyone has to use, but in fact no one likes to use, either because it's very unwieldy to use or because it presents a single monolithic front to several different groups of users. And a very good application for artificial intelligence is to build an intelligent front end to that huge existing piece of software. Also, you can leverage to human systems. Take advantage of the human experts that you have in your organization to increase their productivity, to increase communication among people, to help train new experts faster, that kind of thing. I think also it's important to pick problems where AI has a chance of succeeding, where there is some knowledge that can be captured and automated. One of the strangest experiences that I had at Stanford was when a professional gambler came and talked to us, asking if we were interested in doing an expert system to help him, I believe it was with playing craps. And he would give us rules that sounded frighteningly like Meissen rules. You know, if a 7 has come up 3 times in a row, then this is how you hold the dice before you throw them. And if we hadn't known that no expertise could exist for that task, we might have been lulled into working on a system for that task. I think it's also important to pick tasks where the level of expertise that you have available to tap into is much higher than the typical practitioner's level in that task, so that if you even do a partially successful job of capturing some of that, you've got something that's worth having, something that will help the average practitioners. And then there are also plenty of tasks where the expertise that's needed is difficult to deliver, either because there aren't very many experts or because you're delivering it to a spacecraft that's a few light minutes away from Earth, or because you want it to function very quickly, like managing electric power grid flow. I think the final thing that I want to say about choice of tasks is that you often win by choosing a task that requires a moderate amount of detailed knowledge. If the task requires a lot of common sense knowledge, like understanding free-form conversation such as we're having here, then you're doomed to failure because the number of things you'd have to represent might be on the order of hundreds of thousands or millions. If the task requires just one single narrow, snazzy algorithm, then again, you're almost doomed to failure because you're better off to take a conventional programming approach and program in that algorithm. But in between the two lie a large number of tasks that require a moderate amount of knowledge which can't be captured all at once by talking to an expert with a blank pad of paper in front of you, but knowledge which can be gradually accreted over time. And I think that's really the major opportunity, is to find the right tasks, find the tasks that lie between those two extremes, and have the courage to say, even though we don't know exactly how this program is going to work, we have faith that, based on all of what's happened in AI and in expert systems in particular, if we talk to this expert, if we gradually accrete small rules of judgment, small rules of thumb, the program will eventually attain an adequate level of competence.
Let's try to get a little more specific on that. One of the areas you mentioned was an interface to a complex software system. You have an example in mind?
One example is most VLSI CAD systems.
We have a very simple one. We wrote an analytic model for configuring computers, for deciding, given the amount of terminals you want to handle, the speed of response, how much memory, how much DASD, disk storage do you need to put on the system, and that was an analytic model that was written. And most of the people in the field didn't know what parameters to put into the model, how to manipulate that particular model, and it was useless. We wrote an AI front end to that, which guides the systems engineer through what's being asked of him. It's a simple program. It's only a few hundred rules, but it makes that program usable for, in fact, for meeting the performance objectives of the customer.
The SACON program is an example of that also.
How long do you think it's going to be before embedded expert systems become part of the product definition process for any piece of sophisticated equipment? That is, all instrumentation will have onboard expert systems for diagnostics, maintenance, perhaps graceful recovery from failure, things of that nature. How long do you think it's going to be before we see that as a pervasive application throughout the whole instrumentation field?
I know that's happening already, of course.
It's beginning. I said pervasive.
Pervasive?
Where have you seen it so far?
Well, our own RTPC has a diagnostic shell in it.
DEC is delivering a a system now with an expert system for tuning the operating system. And Ford put out a note to its robotic suppliers requesting comments on their views with regard to providing the diagnostic manuals on an expert system with the delivery of a robotic system.
Well, the statement was a little stronger than that. They said they weren't going to buy the systems unless they had diagnostic expert systems that came along with them.
But I think a number of people miss the point that diagnostic and maintenance expert systems are also excellent tools for educating operators. They really perform a dual role. And I personally feel that embedded expert systems and sophisticated instrumentation of all sorts is going to be the norm within the next 5 to 7 years.
Yeah, I would have said 5, 6 years. I would agree with that. You'll see that as a requirement. Now that may sound painfully slow to some of you, but it's probably a reasonable time scale for an industrial application to take hold. Very fast, in fact, I'd say. You know, getting back to what Roger was saying, I think his point, when you talk about AI, that's not clear. What we're really talking about in commercial sense is mostly expert systems. And expert systems, I agree, may be a misnomer. Getting the question you asked is, what do you look for? I often describe it as you look at trying to automate some technician-level task, not to be automating really an expert. In an insurance company purview, let's say, instead of talking about the senior underwriter or the junior underwriter, it turns out that about half the underwriting gets done by clerks. Those are the people you can help the most, the easiest with the state of the technology, and that's where the biggest errors are, in fact, made, not with the senior underwriters, who are the guys who've got 5 to 10 years experience in the area and really know about how to go about the problem. It's the clerks who turn over every 2 years that one needs to.
No, I absolutely agree. I think that one of the things that the misunderstanding about this problem of expert systems is that there's this word, okay? Now, if we take away the word expert systems and call them dumb systems, it wouldn't impress people as well. But dumb systems is what we're really after. For example, my favorite system is a bank teller. The rules that you would need to simulate what a bank teller knows are not large, and not the same as an engineer. The problem is that, and this is why I think that I'm really objecting to your comment of only expert systems. I happen to think that natural language is the key issue here, not only because I do natural language, but because I also think that AI ultimately has to be transparent to the user. It shouldn't be in a situation where you're knowing you're dealing with an AI system. It should be that you're dealing with something, and you don't know what the heck's behind it, and don't care. And my premise is that rather than deal with, say, a bank teller who only knows the level of training they've had, but doesn't know answer the question you want to ask, you're much better off dealing with a system which has a whole set of rules in it, but not anything like 2,000, not even in the hundreds. And its expertise becomes important to you because all of a sudden it can answer your questions. Because when you ask it something, it knows the answer. It turns out that knowing that answer was trivial, and that anybody who worked at the bank would or could know it, but it changes the concept of what AI is about. I think AI is about, in terms of a business sense, AI is about the building of transparent products, not expert tools, but products that are going to be sitting in the marketplace available to everybody. But the key to that is they've got to understand when you talk to them or when you type to them, because you're not going to be able to learn how to use them. There'll be too many of them available.
Well, we like to call them knowledge-based systems. We don't think they're really dumb either, and we don't. An expert may be a misnomer, but they're certainly knowledge-based systems is the terminology we like to use.
That's fine.
Yeah,
I'm just playing with the word.
after you disagree, Ed, I want to disagree with him too.
Yeah, well, I think we probably disagree on the same point. We're talking about the modeling of certain aspects of an expert's behavior. Now, an expert is certainly broader. A human expert has a scope which is broader than the portion which we capture in an expert system. But you do want to solve those problems well at a high level of competence that an expert solves at that level of competence. Now, in addition, the expert has certain learning capabilities which we don't yet have in programs. We aspire to put those into programs. But there's no reason why we can't talk about expert levels of competence in solving certain particular problems within that domain.
With that in mind, I'd like to return just for a moment to the example that you brought up, Herb, about the clerk versus the more senior partner. Now, there were
two things that were discussed with relationship to those types of expert systems, or those knowledge-based systems. One was that there's more utility in building that system. It can get more use, and the second was that it's easier to build. Why are those two true?
Now, just the first one is easy. I mean, in one firm we looked at, there's 60% of the underwriting is done by clerks, another 30% by junior underwriting. Only 10% of the underwriting is being done by the senior people. And those are, as I said, the most experienced. So clearly, you can help the 90% of the people much easier than you can help those top 10%. So there's just leverage and sheer.
To have an expert system that figured out how they were able to avoid having to do all that work.
But that's what the senior people are all about.
That's what I'm saying.
Wouldn't
Right.
the highest leverage be obtained by creating an expert system based on the expertise of the 10% and distributing it to the 90%, so that the 90% can...
No. What you got in almost any insurance company is a set of underwriting rules, and those are sort of loose. They're in books. And if you want to do a particular specialty of underwriting, for instance, you may want to go back to your main headquarters, because that's where if you run out of trouble with the books, you go to those two experts. But those books are sitting on the shelves, and now the problem is I'm sitting in my branch office, and I have to page through all these books to find the applicable rules and begin to make interpretations. And people are much better at dialoguing that with a computer, with an expert system.
Let me give you an example of what I'm talking about. General Motors is working on an engine diagnosis expert system, and they've been advertising that in the New York Times Magazine and other places. And they show a picture of an auto mechanic bending over a car, being advised by an expert system on how to fix the car. And the text of the ad says that they've gathered up, integrated, and put to work the expertise of the best General Motors diagnosticians and made it available to the person repairing your car in the workplace. Now, isn't that a very high leverage application of expert
Sure.
system?
But most of that, I think, I have a slightly different paradigm of how that's done. I think that the underwriting experts wrote these underwriting manuals. And now the question is, can you capture those in computer form? Rather than this, and you use those experts to help determine those manuals. I suspect in GM's case it's the same thing. There are diagnostic manuals and diagnostic procedures, and you want to make sure those are done well and embodied in the program, rather than worrying about the esoteric 1 or 2% of cases which are new problems where you might want to go back to the experts.
But I think you're both capturing...
May not be... Go ahead.
I think you're both capturing the two major current uses of AI technology. One is to speed up and make more consistent the performance of technicians at some detailed task, and the other is to actually disperse a little bit more expertise so they do a better job than they did before. And both of those are important. One of the recent art applications for American Express was to speed up the rate at which credit authorizers do their job by helping choose what screenfuls of information they see, and thereby reducing the average number of seconds it takes an authorizer to do their job. That's very different from trying to disperse the kind of expertise that the best authorizers have, which is still a very worthwhile task, but it's a different task, and I think those are the two.
But you see, this distinction crystallizes the problem here, right? And you see there's an underlying conversation going on here. It ought to be made explicit, right? Ed believes and has talked about expert systems to the point where we are thinking that the goal object of expert systems is the modeling of the Nobel Prize winner, and in fact, Ed started with that at that point of view. I am agreeing with Herb, which is that the premise of the reality of expert systems in the real world is going to be the simulation of the lowest level of people, not the highest level of people, because the highest level people have all kinds of other properties that make them very valuable, very unsimulatable because they learn and change and so on. And in fact, from a business point of view, probably not the point. Because the real point, if in terms of speeding up production and making companies work better, is to take the lower level employees who require a lot of training and then quit after half of them quit after they've got that training, who don't do their job very well, take a long time to get up to speed, and in my case, with natural language, those people frequently interact with the public and do an annoying job of it,
Right.
that's the area that AI can be really productive in.
I have no argument with that. So let me take a concrete case and try to understand what you're saying. Let's take the case of the people who really turn over a lot, the young people brought into the armed services to, who end up doing diagnostic work on avionics. Now, what I would like to see is an expert system that helps those young people diagnose and repair avionics equipment rapidly, where that expert system is based on very good expertise about Air Force equipment. So I'm saying that we capture the best expertise and deploy it to the people like that to make them better. That's all I'm saying.
AI, particularly knowledge-based systems, is helping to make knowledge more tangible. The technology encourages us to articulate knowledge in detail, including not just overall procedures, but also the special cases, the exceptions and rules of thumb. Once it's been captured, it can be scrutinized, it can be augmented and tuned. It can be distributed and applied more widely. At the same time, decisions can be made more consistently. It improves productivity and quality simultaneously. It can be retained, avoiding the loss of experience of retiring personnel and holding important but rarely used knowledge until it's needed, such as diagnostic procedures for highly reliable equipment. It's been applied for cost savings and for revenue production. The most common applications have been for equipment diagnosis. Other important applications have been for design, sales support, process control and scheduling, getting policies and procedures out of books and into use where they're needed, reducing administrative burdens, putting financial strategies and competitive analysis to work, even doing magazine page layouts and matching customers more precisely with available products. In other words, applied artificial intelligence is finding its way into a broad spectrum of businesses and into nearly every corporate function. Companies have recognized the strategic significance of this technology, and many are taking corporate initiatives to speed its application throughout the organization. Let's take a look at a few. You may have seen an indication of General Motors' commitment to artificial intelligence in television commercials.
What's that?
Harry, watch it.
I'm watching it.
Harry,
What?
my mold.
Now, why didn't you cover that thing with some of that stretchy stuff before we left?
Why didn't I? Who was it who said, Rita, we're going to be late? Oh, my.
What's that? Shh, shh.
Don't you shush
No,
me.
what is that?
What's what?
That.
Give me that.
Yeah, that.
Well, it's nothing. Now we're late.
We better stop.
And they're off. Number 3, Bucks County, broke quickly, followed by number 6, Dan Ken. Number 1, unnamed Colt, moving up on the inside.
If you're not too busy, we could use some help.
Sounds like you got yourselves a real problem here.
I don't know what happened. Just started missing all of a sudden, and then...
The engine all right?
Have you got a fridge?
You think you can fix it?
I think Charlie and I could have a go at it.
Charlie, a mechanic?
Engine expert.
Watch the washing machine. It's a present.
Sorry, Ellie, I don't know what time we're gonna get there. No, I don't know what's wrong with it. I'm not a mechanic. Hey, listen, is little Jimmy around?
So now, Charlie, old buddy, what do we got here? Okay, Charlie, computer checks out. Now what? Unknown. May I'd say so. Well, it just happened out of the blue.
Are you sure about that? Okay, I'm doing it.
You know, Charlie, I'd have never thought that.
That was quick.
Done and fixed. Just a plug fuel filter.
You're sure lucky to have that Charlie fella here.
Don't I know it?
Well, thanks again. And thank Charlie for us.
bet. Y'all drive carefully.
Did you hear him?
I heard him.
My new
What they referred to as Charlie is based on an expert system that's currently being deployed called Engine. General Motors expects AI to have a significant impact on the company. They're building on their experience in applying similar technologies, robotics and machine vision, to accelerate the utilization of knowledge-based systems and natural language. Barbara Sanders, Director of Technology Planning and Implementation, told us how it's being done.
We see AI as being comprised of several major components, including robotics, machine vision, knowledge engineering, natural language, and a collection of other things we put in the category of other. In the knowledge engineering area, we have a major thrust in trying to accelerate implementation of the technology. We have an experience base gained from robotics and more recently from our machine vision work that provide a model for what we might want to do to accelerate a new and emerging technology, one that's beginning to make that transition from the lab to more commercial, a more full-fledged commercial product, and therefore could be useful in an environment like GM. In an effort to do that, the corporation, I think, has done a number of things to indicate its commitment to the technology. Back in 1984, we made an equity investment in Technology, a firm on expert systems software tool development firm on the West Coast. And I think we made a following investment about a year later, and so we have about over $4 million investment. That is part of our overall means of trying to accelerate the technology because it's an area where there's so few resources in terms of experts in the area that it's difficult to hire them to do all of your development in-house. So part of our goal has been to leverage our efforts and use outside developers where we can. And in the areas where we identify would probably be our most immediate application areas, Technology offered we thought the best expertise and tool to meet our needs. In addition to that equity investment to use the outside resources, we've also, I think in January of '85, the corporation created an organization internally, which is the group I have responsibility for. It's called Artificial Intelligence Systems and Planning. And they approved a head count to staff that organization. Again, not a large head count because the idea is to leverage resources outside where so much of the expertise resides. And often we have difficulty getting them to come to the Midwest. So we have created a small group whose charge, again, is to do those things necessary to accelerate the implementation of the technology and direct the divisional efforts so that we get a united approach to the technology as opposed to some of the disparate efforts we've had in some, and others have had in some other technology efforts. We often act as consultants. And we work not in place of outside vendors, but in addition to them, where we may play a screening role, we try to identify what tools may be appropriate for a given application, and then we may work with the division to select an outside vendor. That coordination role also includes getting divisions to work together on joint projects.
Can you give me any examples of applications?
Well, we make the statement that we think expert systems will apply to all aspects of our business, and we really believe that because in all aspects of our business there's some level of expertise that's often caught in the situation of being scarce or perishable, and those kind of things fit the definition of where an expert system might be applicable. So we say we see expert systems being applied in engineering, design, manufacturing, sales and service, and our financial areas, and there could be others, other administrative areas, personnel, whatever you. And we have systems underway in each of those areas, not all of which I can talk about, but I can mention a couple that we've talked about more openly. One is an engine what we call Engine, and it's an engine diagnostic advisor. And we selected that system because it offers an opportunity to help us address the sales and service environment. Not just because they're the sales and service environment, but because our product has gotten more complex. And to be able to diagnose and repair problems associated with that complex problem, a complex product, we need ways to train our technicians in a more rapid fashion. And an expert system like Engine offers the opportunity to do that. Another area where we think there's tremendous opportunities in the manufacturing area. If you think of the whole concept of process control, I mean, that's a big area. We think that's an area where we need to have a lot of work done. Recently at AutoFact, at 86 AutoFact, we demonstrated a system that we call Vibration, which would again fit more into the sales service area because it's a diagnostic tool for the service technician to identify problems in the drivetrain area, vibration problems in the drivetrain components. So that's another attempt to enhance the capabilities to diagnose problems early by our dealership technicians.
Computer Resources Incorporated, CRI, is a software company in Copenhagen that's added AI to its stable of technologies. They told us about how this offers new opportunities to increase their customers' productivity, and also about some of the risks involved in building a business on a new technology.
Because I think the mortality rate of companies trying to make business on AI will be very high, in the order of 80–90%. And we do not want to be part of those 80–90%. We want to survive in this area. And I think we know how to survive.
How are you going to do that?
First of all, I think strategic thinking and planning is very important. You need to focus your efforts, you need to know where you want to go and what areas you want to go for. Secondly, you need to be prudent financially. You need to be responsive to market needs. So we don't believe in going to ourselves, to going to our own place, making big investments and then coming back to the marketplace. We think that's far too risky. And thirdly, we need to go for functionality. We sell functionality, not technology. This means that you need to identify areas where knowledge-based systems, artificial intelligence, has something significant to offer compared to conventional data processing.
You're working on quite a range of AI projects here. Can you give me an idea of what that range is and how AI is going to have a significant impact in those areas?
In general, we are working on a number of projects for clients in public administration and in the financial services. To give you just one example, we are developing a system for the Danish customer service. They have as one of their main tasks to control the VAT, value-added tax, accounts of companies. And we are developing a system which can support the customs officer during his inspection of the accounts and all the papers, all the figures of a company, including both trivial things, spreadsheet, report generation, and knowledge-intensive tasks. The experience of the experienced customs officer and the knowledge in law and other legal things which applies to value-added tax. We are implementing that on a portable PC which the customs officer can use as his personal workstation when he visits the companies. But in order to arrive at the target system, we have used dedicated AI equipment, we have used Lisp, we have used tools like Key in the knowledge engineering process in the systems requirements phase of the project. And we have been very happy with it, and the customers have been very happy with it. They have been part of the process instead of we have been doing alone, as is usually done with conventional data processing.
What will be the significance of AI in the software business overall?
Because I think significant sectors of economy are still effectively not automated or are not supported by data processing, namely the sectors where knowledge-intensive tasks are prevailing, and that is public administration and financial services. What is happening there requires knowledge, requires experience, and conventional data processing with a huge capacity for number crunching is not terribly relevant for their jobs. Now with knowledge-based systems, we get opportunities for also providing assistance, support to their jobs. And I think with significant productivity gains as a result. So in public administration, financial services, I think we can expect significant productivity gains through this technology.
Westinghouse started building a technology base in AI in their research labs 7 or 8 years ago. Since that time, they've developed applications in nearly all of their 23 operating divisions. And to coordinate this activity, they've established a committee to enhance the communication between the people who have the problems and the ones who understand the technology.
How extensive is the AI activity here at Westinghouse?
Actually, as far as Westinghouse is concerned, it's quite extensive. One of the reasons I'm involved in it is that many divisions have AI programs. And the way in which we are structured, each division is part of a business unit which is autonomous. And I'm a member of the Engineering Manufacturing Advisory Council that Westinghouse sponsors. And our mission is to communicate across these business units. And my activity in the area of artificial intelligence is to make sure that different business units, different divisions know what's happening in other parts of Westinghouse. It's actually a multi-million-dollar activity as far as the corporation is concerned.
Has there been a corporate commitment of any sort to artificial intelligence?
There's a commitment to it. It's probably closer to what I'd call a business unit commitment, back to the concept of autonomous business units. And we use it in many, many different ways. We use it as an internal processing tool for our own designs and manufacture. We use it as a product that we sell directly. For example, the turbine generator diagnostic system that you're going to be looking at later. And we also use it as a part of other hardware that we sell, mainly in the defense area.
How do you coordinate the AI activities here?
The Engineering Manufacturing Advisory Council sponsors a subcommittee for a users group in the area of artificial intelligence, and I chair that group. And we meet every other month. And we constitute a group of over 100 people from various divisions and business units within Westinghouse that are all either active in AI or interested in AI. And my function in that group is strictly as a facilitator. I try to bring together the AI expert on the one hand and the person or persons with problems on the other hand, and see if we can marry the two together. The format of the meeting is one in which we devote 4 hours to the session. Generally, we have a success story where a presenter talks about a success with artificial intelligence that his particular group has encountered and describes it to the remainder of the audience, and then there's discussion of that success and questions like how did you do it, how long did it take, what did it cost, how did you start, what equipment did you use, what problems did you run into, and so forth. The next part of the format usually consists of a prepared discussion of a problem. And this is a person that comes to the meeting with a problem that may or may not be amenable to solution by artificial intelligence. And he presents the problem, and he then asks the group for advice and counsel. Is this a problem which has a solution within the bounds of artificial intelligence? How should I go about it? What's a reasonable time scale to look for an answer in? And that's a very lively discussion, an interactive discussion. Following those two presentations, we generally have a round table discussion where everybody at the meeting discusses what it is that he or she has been doing in the area of artificial intelligence.
I would say that 1/3 of the people attending the meeting come strictly to learn what's going on in other divisions. I intend to keep that committee active as long as I get people volunteering success stories and problems. That's the measure I'm using, and to date I've not run out of candidates for that.
How would you characterize the impact of AI on Westinghouse as a whole?
In some divisions, it has had a very major impact. For example, in the steam turbine generator business, the ability to diagnose operating turbines and generators, online diagnosis, is a major step in improving availability and reliability of those machines. A single day's outage of a turbine generator of large size can cost up to $1 million.
We took the expert systems approach after working in the area of probabilistic techniques because we recognized after spending some time in that area of probabilistic approach that the size of the sensors, the number of pieces of data we're going to have to handle in the future would overwhelm that type of system. And as we saw that coming, we went to a expert system approach, which using artificial intelligence gave us the tools we needed to make the project successful.
You have a number of systems installed now. What have you seen as the impact?
We've been very pleased, Harry, with the results we've had on one particular project that started off using diagnostics in combination with a number of engineered equipment upgrades. And through that program have watched diagnostics be the tool that predicted which unit and at what time had to be repaired in a scheduled sequence. We did not have the capability for repairing all the units at once, nor the techniques for diagnosing which one really needed help the earliest. Using diagnostics, we were able to find those answers, and we, through that project, took the units from a previous 3 years ago history of running at a 1.4% forced outage rate on the average, down to 0.2% forced outage average this year. We also, looking at the availability side, went from 95% 3 years ago to 97.8% this year.
So that's about 2.8%, which is roughly 9 days or $9 million.
That's correct.
How does the turbine diagnostic system work?
Well, it works by having a data center out in the power plant which collects the data and transmits it here to Orlando to the diagnostic center, which you're in. The diagnostic center then takes the data, does a diagnosis, and sends it back to the power plant where it's displayed on a touchscreen color CRT to the operator. The operator can also look at the data as if it was a conventional monitoring system. This way he knows the condition of his equipment much better than he would if he had to make the diagnosis simply based on the data himself, because he has not had the same experiences that the people that put the knowledge into the rule base have had.
How many sensors are there in one turbine generator?
Oh, there's, it varies according to the design of the machine, but there can be anywhere from approximately 120 up to 250.
The number of rules can be misleading, but what is the size of these systems?
Well, these also, the number of rules varies, of course, with the particular generator, but they run from 1,876 rules up to 3,000 rules at the present time. Although that changes as we gain more experience, put additional rules in some cases putting additional monitors or sensors in the plant, where economically justified will increase the number of rules.
Mm-hmm. Where do you see that figure going?
Well, we see it going above 10,000 before too long for a given plant that would have both generator, turbine, and our chemistry AI diagnostics in the plant. And then as we expand beyond those pieces of equipment to the total plant, it could go up to 20,000 or more rules.
What's the impact of these systems on the operator?
He needs what I call actionable information, not just information, because there's all kinds of information around. What he really needs is information that will help him make a better quality decision. What you're after is, first of all, a diagnosis of the condition of the equipment, and then secondly, you want a recommendation. Given this state of things or this diagnosis, what do I do? And so we give the operator both things. So he has a much clearer idea of what the problem is, because basically you are giving him information that is coming not only from the data, but from the knowledge of people that have seen this same type of failure other places. So now, instead of just having to go by his own personal knowledge, which maybe in many cases he hasn't experienced that type of failure, where with the diagnostic system he has the value of people that have actually seen that failure, because on the type of equipment that we diagnose, on any one given turbine generator, there are very, very few failures, so you have very little chance to learn. But with a centralized approach, as we have here, we can learn from each unit that is attached to our system, plus, of course, the service engineers that go out and investigate individual failures. So all of that is factored in and made available to the customer.
Well, I think there's been a pretty large impact of knowledge-based systems in Westinghouse. Not as dramatic, perhaps, as the diagnostic with $1 million a day leverage on it, but we have used it in the processing of nuclear fuel, for example, and dramatically improved the quality of that product and the productivity of the factory that has been producing it. We have used it in the real-time scheduling of engineering activities, taking into account the fact that we do have limited resources and changing priorities. And it gives us a very effective tool for matching our needs to our resources and making sure that we are getting the right people on the right jobs at the right time. We've used it in the design of airplane generators, variable speed, constant frequency, where a design engineer has got to make a very complex optimization. And we've been able to reduce those rules to an artificial intelligence system and have a computer design the generator in much less time than it takes a person to do it. And again, with higher quality and higher productivity. So I'd say the impact has been very dramatic in some business units, not so much in other business units. But it is somewhat surprising that it has the applicability that it does have. Even the Westinghouse Credit Corporation has uses for artificial intelligence. Some of the processes they use lend themselves very well to artificial intelligence procedures.
Look, I guess I'd like to needle this community a little more, the community of VLSI people that we're just addressing.
Please do.
We're in a situation in which they complain desperately about their competitiveness.
Yep.
They're losing out to the Japanese. We're in a situation in which the design costs of these devices are substantial, so that making an impact on design cost would be a big deal for competitiveness. We're in a situation in which time to complete is very important, because the technology keeps changing and it would be an important aspect of competitiveness. So I can't understand why there hasn't been, in that community, therefore, a greater effort to do well what we traditionally do well, namely to cast our ideas into software.
Yep.
And put that at the service of enhanced productivity.
Look, let's look at this. What the microelectronics industry has dealt with over the years. You know, for a long time they worried about how to make things, and today, you know, we have a reasonable knowledge of how to make things. Then they worried about not only how to make things, but how to design them. And everything you said focused on the issue of how to design them. I submit to you that the bigger problem is not only how do you make them and how do you design them, but what to design. That's the front end of the process. What is it that you should design? Lots of tools available to the designer these days once he knows what it is he wants to design. But taking those initial steps, what is it that I should be designing? How do I deal with this constraint?
I recently wrote a book on creativity, on how to become more creative. addressed to the masses. It isn't quite out yet. In this book, what I said was I thought the biggest problem in creativity was getting reminded. In other words, if you are in a situation where you want to answer a question like, what do I design? You have to be reminded of lots of things that will cause you to look at them to say, this is what right. So that the trick, what you want to find if you want to enhance creativity tools is you'd like to build reminding tools. Tools that bring other things to mind. I happen to find that my favorite personal way of doing this is to watch movies. Because you never know when you're watching a movie what new thing is going to pop up that's going to cause you to think about something you just absolutely weren't thinking about. The more you can force that thought within a constrained area, if you want to have people design, as I said, you want to have people design toasters, then we have to have lots of reminding experiences that in some way are related to toasters.
I think something like that has happened in software, but it's not actually reminding tools. What's happened is the ability to do exploratory programming and rapid prototyping.
Exactly.
So that what people can do is to try things out. And when they see what their original ideas were that don't work, they can try something else.
Just having a powerful workstation running C, for example, is not the kind of environment that Harry's talking about. That forces this creativity out of people.
I still want to needle this community. I'm sorry, George.
What do you want to needle them on? I mean,
their lack of progress on the design question vis-a-vis VLSI. It's an area which is characterized by a high degree of combinatorial activity, for which there is substantial expertise that can be captured. You talk about workstations, but high-speed Lisp machine workstations have been available for some years now. What is holding them back?
Well, first of all, there has been a lot of progress. You don't design memory chips with 8 million devices without having a lot of progress made. What I'm talking about is not the progress in layout and writing, not the progress in simulation or verification. What I'm talking about is the front end of the process. And I submit that the problem is that these guys have not been used to working with the tools that Harry's been talking about. And that's going to take a little while before they become used to working with those tools.
Well, at the risk of being shot by all of you, I will maintain that they've made more progress than the programming community has.
Oh, sure they have.
In terms of number, if you want to take a measure of number of circuits per design or per man year, they do a hell of a lot better than
and they handle complexity far better than anybody else.
So the tools are there, and the tools have improved quite a bit. I think he's looking at the front end thing. So one can argue in terms of what's been done on the programming processes and worse.
What I'm saying, Herb, is that we've made a lot of progress in VLSI design. We've made a lot of progress in design automation in general, not just VLSI design, but mechanical design automation. All I'm saying is that's not all there is. There's a synthesis task that hasn't really been worked.
But it hasn't been worked for software either, and it has to be worked for software.
No, in fact, I think software is harder because there are more degrees of freedom. I think one of the reasons physical design always works out better is nature has built in some constraints that help.
The chip is so big, that's
really helps. And it's very hard to give people languages that have built-in restraints as well as abilities that actually help them write programs better.
We in fact do things, and we do have concepts of macros and hardware which are continually reused from one chip design to another chip design, as we well know, in macro libraries, and you find very little of that in the software. There's very little reuse of code.
Are there any other industries you'd like to pick on, Ed?
Well, yeah, I think let me talk about management of corporations as an industry. One way of approaching this is to ask, as one looks around at different segments of professional work or different industrial segments, where have the applications been lagging, where one would have expected applications and the applications have been lagging? Now, I would submit that from the general point of view of the existence of heuristic knowledge, the ability to apply heuristic knowledge successfully in the normal run of everyday business, management processes would have been one of the targets, should have been one of the targets. We should be seeing more conventional management applications as illustrative of the expert system technology and application, but we haven't seen it. Particularly in manufacturing, we know that most of the jobs, I say most, it's about 2/3 of the jobs in manufacturing are the so-called non-touch jobs, not involved with assembling anything, involved with thinking about the manufacturing process, scheduling and control and factory floor routing and so on. And yet, one hears a lot of noise about robotics applications in the factory, and yet very little activity on the automation of the management-oriented, non-touch activities in the factory. Another aspect of this is that these tend to be, again, this class of combinatorial problems that ought to be easy to automate. And I think that the problem here is that typically the management is the group that is making the decisions concerning what projects to approach or not approach, and there is this saying, I call it Lederberg's law, which is everything is automatable up to but not including what I do. And I think that we have to have some meta-management who's understanding that that law is in operation and proceed to begin the process of automating some of what the managers do. It's a very high leverage application. That addresses directly the question of who to attack next. Management. But I have looked a lot at corporate exploitation of the expert system technology. And I think, well, perhaps we can dimensionalize it according to the kinds of payoffs that the corporations believe they will get and have in fact achieved. One dimension of corporate goal setting is cost saving in the use of the technology, internal cost saving. The second motive, which is the one that in my view has been least successful to date, is the amount of increased revenues that a company sees by selling a product or a service, as opposed to the cost saving that it sees when it rationalizes a process. The third viewpoint is a return on investment viewpoint, which says that for a small amount of effort invested, there can be some significant gain, and they actually compute ROI figures. For example, in one corporation I spoke with recently, the canonical expert system was one which was done in a month by a person using a PC expert system shell and paid back $200,000. Now, $200,000 doesn't sound like a home run. It sounds like a perfectly fine single, but the ROI on that is tremendous. Another goal is to make possible certain designs or processes or other kinds of valuable activity that simply were not possible before because of what I view as the order of magnitude effect on human productivity. In one particular case that I looked at, a company that was designing lenses could try out 10 times as many lens designs as they were able to before. And that was the source, they claimed, was a source of great innovation, to be able to do 10 times as many designs. Now, not all of them worked out, but the ability to do them fast was very important. One of the dimensions that people are looking at is the question of quality improvement. Is it possible to get something done better because it's done by an expert system? Another one is to improve the uniformity of results. There's one situation where I saw a very large knowledge base being done by an insurance company where the motive, it was not necessarily true that the system knew more than any of the individual insurance underwriting experts. It was the case that the company really wanted all of the experts to process all of the decisions in more or less the same way, rather than in some kind of ad hoc way that showed up among the experts. These systems are delivering reasoning power and knowledge access power to people much faster than these people are capable of doing the jobs themselves. And a typical, let me give you some typical numbers. An expert system to design a floor layout for a mainframe system is brought to a site by a field engineer and is used to lay out the machine when it on the floor. Typically, that task takes a human engineer, field engineer, 8 hours to do. With the help of the expert system, 15 minutes. That's a productivity enhancement of a factor of over 30 right there. In one of your video symposia, there's a person from a company typing away at an expert system. It happens to be a chemist, and the person says something like, this task used to take me N hours, where I think the number was something like 8 or 12, and now it takes me 10 minutes. Do the multiplication there, and you see somewhere between a factor of 10 and a factor of 100 productivity enhancement. The lens design company, factor of 10 right there.
We find that very common.
A company that has been designing an expert system to the front end of a CCD simulation system reports a factor of 10 speed up in being able to use the CCD simulation system, which means they can try out many more designs. So those numbers are typical, and they are staggering numbers when you consider the percentage productivity increase, when you consider that professional work is an important part of our economic system, that last year the economic productivity of the United States grew 0%, and we're talking about thousands of percent productivity increase for an important segment of the economy. We haven't seen a technology like that since the early introduction of computers in the 50s, and before that you'd have to look to jet planes and telephones and things like that. This is that kind of technology that we're talking about.
I'd like to get a reading on where the business of natural language applications stands today, in the opinion of this panel.
The business of natural language.
The business of applying natural language, yes.
Well, I don't know. I can probably only talk about my own company, but in our case, we have 3 distinct types of products. The first is a back office program to read text as it comes over a wire, which is originally developed at the university for the reading the news wire, but has been applied for the Coast Guard in a film I think you're showing, and has been applied in the back offices of banks for reading messages, and is now being applied in financial dealing rooms. It's all a question of somebody typing a sentence to somebody else that a machine could read and do the action. We have a second class of products called advisory systems, which are programs which will have English language conversations with you to reach some goal, usually selling you a service of some variety. And the third of natural language training systems, which allows a student to be able to be more aggressive rather than a passive student. Rather than watching a computer and push a button for the next page, he can ask a question, and you can put him in what I call Socratic mode, where you put him in funny situations and he's got to figure his way out of them, and he can speculate and wonder about what's going on and ask and form explanations and be answered and so on. I think that that business is a business which takes a long time to grow, and the reason you haven't heard much about it is that you can't sell services unless you have a partner who has decided he wants to sell services that way. Cognitive systems can't be selling stocks. We need somebody who sells stocks to sell stocks, and it takes a while to make those partnerships form, to test the technology, so on. So we have a lot of things that we haven't been able to announce because they've been under development for some time and haven't hit the market yet, but they will. I think there's another business in natural language called the front-end to database business, which is something I haven't personally had a lot to do with, largely because I think natural language systems are inhibited by a lack of knowledge. And if you build one that's supposed to work for any database, that means it won't have any knowledge at all of the database. And so it's like asking questions of a blind man, and I think in principle it won't work too well, because you're asking really, the companies that work on that translate language into file names and field names and really don't know what those names mean. And I think ultimately that becomes a very difficult thing to win strongly in. Once you promise somebody the right to type natural language, they're going to believe you, which means that they'll think you can formulate things any way you want. And you better be able to provide that service, or you're going to make them pretty angry.
Well, one of the things that I was frankly surprised at, we have a story on database access through natural language, and it turned out to be a much stronger story than what I had expected. The way they get around the problem of the limited domain is that these systems are primarily used internally inside of corporations, and the language that is used internally that relates to the data in the database is very constrained. And what we've seen is that people are able to make use of sophisticated database systems through a natural language front end It's very difficult to measure how well a natural language interface understands language, but that's what's most important to know. Intellect, a natural language interface product from Artificial Intelligence Corporation, is in use at a small insurance company called Homeowners Warranty. We spoke with Brian McCarty, a claims adjuster who's been using the system for about 2 years now, and with Linda Farrell, who's in charge of the Intellect system in their data processing department.
I'd never sat down in front of a computer before, and I've always been shied away from them. I just wasn't comfortable with them. Knowing the language and the natural language that is used with Intellect, I have no problem with it. I wasn't afraid of breaking anything. I wasn't afraid of getting no response or incorrect responses or any frustration in learning how to use it because it was natural language.
How do you like it?
It's really been an amazing asset. It's been, as I see it now, an most invaluable asset, and I truly don't know what I was doing without it. It has been an immense time saver.
How?
In my particular position, it's necessary that I do a number of ad hoc reports that are due, rather the information that's necessary yesterday. And one particular case that I can think of, in obtaining some certain information and putting it in a certain form, would have taken me 3.5 days. With the Intellect system, I was able to gather the information, put it in the form that was necessary in about 14 minutes. Being in the insurance field, I deal mainly in our company with claims and disputes, and it's necessary to draw up information on a particular claim or a particular builder that is cumbersome with a 1.5 foot tall printout. Now I can turn around, tap it up into the computer, and it's instantaneously in front of me on the screen.
But there must be certain restrictions on your language.
Certainly, the system can't use every term and phrase known to man, but we have essentially been able to input into it, I would think, every phrase and term that we do use on a day-to-day basis. So in that sense, it's unrestricted to what we do and talk and how we talk within the company.
How long did it take you to become effective using the system?
That's a good question. Simply by experience and a couple of phone calls to the computer services department, a couple of weeks at most, and that was just on my own time, and kind of searching out what's there. And but from day one, it was very comfortable to sit down and know what fields are in there and how I can use those fields and simply ask the questions. From day one, I was getting answers to some of my questions. But in that few-week period, I was able to learn what Intellect can do for me, what forms it can take, the extent of the questioning it will take, the compound questions that you can use at one time. That's the kind of thing that did take a few weeks. But again, from day one, you're able to use it instantaneously.
My experience has been that the Intellect system, people who have no computer experience are able to get on the system with very little difficulty. In my case, the managers that use Intellect had, for the most part, no prior experience on a computer at all. We were not an automated company or a computerized company. We had our main processing files were on a computer, but we had no flexibility as far as end users were concerned, and most people had no reason to know anything about a computer because we didn't use them. When we brought in Intellect, we had to add some of the basic computer training parts to the program so that people would understand how a computer worked and therefore how this product would work. From within 60 days of acquiring Intellect, we were able to satisfy about 65% of the management requests for ad hoc reports. Within a year of acquiring the product, we now respond to about 95 to 96% of management requests for ad hoc reports. Or actually, they respond by using the NLAC system.
So they use it directly and don't have to come to the central
They
DP
totally
shop.
avoid the DP shop altogether. They have no reason to come, unless they have a problem with something. But for the most part, it's designed for the end user. Very seldom do I, as the NLAC administrator, get involved in an end user process on the system.
Why isn't natural language in more widespread use?
I
without
can't
qualification?
understand why everyone doesn't have a natural language system. I honestly can't understand, whether it's a large company or a small company. With the number of books that I've read, the number of seminars that I've attended where DP people are constantly talking about the data processing backlog and in fact, James Martin talks about the invisible backlog. Those are the things that are sitting out there not even asked because you can't deal with already what's in front of you. And while I don't believe that natural language is the be-all and end-all of life, it's certainly a viable tool for large companies and small companies to assist them in meeting those data processing requests that are piling up everywhere.
When we did our first symposium in November of 1985, we went out and found some applications of expert systems that were in use that were realizing cost savings and so on. But it was rather difficult to find them. But we did find a number, and now, 2 years later, you can find so many applications of expert systems that it's not news at all.
But you know,
if you go out looking for natural language applications today, you can find some. You can find, for instance, the one that we described at the Coast Guard that was done by Rogers Company that paid for its development costs and the machines that it runs on in a period of 14 months, which is interesting. But you don't find a lot. What I'm wondering is, are we going to have a radically different situation in natural language in 2 years, or?
Well, yes and no. I'll tell you, one of the things I've learned is that there's a lot of resistance to natural language when you start talking to people. I mean, you've heard Herb resist, for example, a couple of times during the course of the day. And it's my experience that people tend to not believe it. They tend to, unless they've sat down and they have played with the thing and start to think about it, which means that it's a harder sell than expert systems. As it happens, something has changed in the natural language business in the last year, I would say. Which is that enough people have had familiarity with expert systems and have started to think about consumer products that they're coming to us and saying, this is what I think you ought to build. And there are enough back office applications appearing that I never thought of. And in other words, it's not as big a business in terms of companies. There aren't 40 natural language companies, each one with another patron who's sitting there and inventing applications, and there's a natural resistance amongst the big companies to think that's a market, because it's such a widely different market than anyone's ever seen before. It means you can sell something in a way that you hadn't sold before. Some people are turned on by that, and a lot of people say, my God, that's impossible, forget that, because it's really, really new. It's radically different, and that's...
It is radically different, and I think one of the very interesting different things about it is that one of the things that really propelled the expert systems applications was the availability of expert system shells on PCs, I believe, because a lot of people could find out at very low cost what that technology was all about. Then they tended to move up to the more sophisticated systems.
Well, we've deliberately not built those shells, and the reason we haven't built those shells is that we're trying to keep the technology in ourselves. We're a little different than the expert systems companies, is that Cognitive is a very close company in the sense that almost all the people were trained by me or trained by students of mine. And the technology isn't out there real well, and we have no serious desire to put it out there in vast quantities because we control it. Yeah. Well, it's just a question. We can slowly take our time to get the products out there that work, and as long as we have enough money in the bank to do that, then we will be able to build good systems and have them speak for themselves.
The application of natural language that's received the greatest attention over the years has been as a user interface that requires minimal training, such as for access to databases. In the 1970s, natural language interfaces were expected by many to be a major success story for AI, but this didn't happen. There are two reasons. First, the quality of the natural language interfaces was not good enough. Users commonly asked questions that were not understood by the natural language interfaces, and it took too long for the users to discover what opportunities and limitations were involved. Second, the advent of personal computers brought with it display-based interfaces using menus and graphics. These interfaces were fine for novice and casual users, especially for the simpler commands and queries. And most commands are simple ones. Display-based interfaces are also less expensive than natural language interfaces in terms of implementation effort and runtime resources. So, through the 70s and into the 80s, natural language interfaces remained a technology of the future. Well, research has continued, and a few companies have continued to sell and improve their natural language products. Some examples being Cognitive Systems, the company that Roger Schank founded, the Carnegie Group, which sells LanguageCraft, a natural language toolkit. TI sells a toolkit called NL Menu, and Artificial Intelligence Corporation, which was, as far as I know, the first company in the natural language interface business. Recently, we've seen natural language interfaces to specific products on PCs, such as in the fast-selling Q&A from Symantec and Clout from MicroRim. These are both interfaces to databases, and HAL from Lotus, a natural language interface to Lotus 123. Also, users have had experience with the benefits of display-based interfaces to sophisticated applications, but have encountered the limitations as well, particularly the limits on expressiveness, an area where natural language interfaces are advantageous. Intellect is the natural language interface product from Artificial Intelligence Corporation, the one we heard about from the folks at Homeowners Warranty. There are currently about 500 installed Intellect applications. After Intellect is customized to a particular mainframe database, it can provide flexible access to data for novice and casual users. And as we saw in the interviews, it seems to work pretty well. Brian McCarty spoke of a dramatic effect on productivity, doing in minutes what otherwise would have taken days. And Linda Farrell saw it as a way to eliminate most of the data processing backlog. To tell you the truth, I was surprised at just how enthusiastic they were. I expected a problem that's seen commonly in applications of natural language interfaces, frustration over exceeding the coverage of the system. Every computer application has limits to what it can do. Some of the benefits of menus is that they reveal the extent and limits of the application to the user immediately through the contents of the menus. Let's say you want to know the average tonnage of a list of ships, but average doesn't appear in the menu of commands. Well, you might be disappointed, but at least you know unambiguously that the application doesn't offer that capability. With a natural language interface, you'd have to find it out through trial and error, and while trying it, you may not know if the question is rejected because the system doesn't do averages, or if you've just phrased the sentence in such a way that the system doesn't understand. Menu-based natural language interfaces have been designed to combine the expressive power of natural language interfaces with the explicitness of menu systems. Instead of asking the user to type in a question, he's presented with a collection of menus on the screen, some of which are active and some inactive. He builds a question from words and phrases that are selected from the menus. As selections are made and the sentence is built up, different menus become active and the phrases within the menus change. What's happening is that a natural language program is dynamically building the menus after each selection, presenting the user with only those words and phrases that make sense with the sentence fragment that's been built so far. In this way, the user is prevented from constructing sentences that the natural language program won't be able to understand. He just isn't given the opportunity. Yet, because the system is driven by a natural language program, it has the same expressive power as the conventional kind. Because the users build their sentences from phrases and menus, the system doesn't have to anticipate all the synonyms and paraphrases that all the users might come up with. At the same time, menu-based natural language interfaces provide the explicitness and economy of menu interfaces. The FRESH system, developed for the Navy, which we'll hear more about later, had two natural language interfaces developed for it, one conventional and one menu-based.
Well, I think it's probably the first opportunity we've had to to take some very difficult interfaces where we have a large database with a database language and a display system with a display language, which requires a fair amount of training, and taken that and allowed just about any user to walk in and ask the kind of questions that they've always asked but never been able to get the answers themselves. They've always had to ask a technician to walk in and ask, sit down at the computer and ask the questions because of the specialized languages involved. Natural language interface of either kind, the natural language menu, has been a boon. I came in 6 months ago and had no idea how to interface with the computers we had available at the time, and I've learned since then, but I didn't have to. I just went right to the natural language menu, clicked out my question, and got the answer back. And in a fairly timely fashion, maybe not quite as fast as the guy that's sitting there who's very knowledgeable in the database language, but at the same time, in not much longer. So it's been a very pleasant experience. To be able, in the long term, from my point of view, I need to know both so that I understand the interfaces and between the two computers, and so we can see where there's problems. And I've done a fair amount of that.
Both the formal query language and the natural language.
And that's a requirement on my part, but certainly not a requirement on the average operator. He doesn't want to do that. He wants to ask questions and get answers. And the natural language menu allows him to ask just about any question he wants without getting an error back from the computer. He may get no answer back because he's phrased his question a little bit incorrectly, but he will at least he won't break the computer by any stretch of the imagination. So that's a very powerful capability. The other interface, natural language interface, IRIS, is much more powerful in its concept, but in practice it's going to be much more difficult to do, I think, just because that allows you to sit down at the keyboard and just write out a question. It's got the same problems underlying a speech-driven computer. You have an incredible complexity of grammar, idioms, and idiosyncrasies of speech and that sort of thing that you have to account for. So you're always going to be a little bit limited there. And of course, the larger that dictionary gets to account for all those differences, the slower the system's going to be. So while that may be the ideal, I'm not sure we'll get much farther or get as far along as we'd like to get. I think the natural language menu will allow us to do everything we need to do. It just won't be quite as natural for the operator. Of course, you don't have to worry about the natural language menu. You don't have to worry about the guy being a poor typist. So I'm not sure what the percentage of typists are in the world, so we've eliminated that problem. And we've eliminated misspellings. So there's some tremendous advantages there over even the natural language keyboard.
Another area of application for natural language technology is in text understanding. Once again, limited domains work best. The Coast Guard evokes an image of rescue at sea, and indeed that is an important part of their responsibility. But because of travel time, those rescues apply mostly to mishaps near land. Distress on the open seas is handled differently. We've come to Governor's Island in New York, a Coast Guard installation where they have a message understanding system that's in daily use. The Coast Guard has established a worldwide system called AMVER, in which merchant vessels voluntarily radio their position, heading, and other information for entry into a Coast Guard database. If a ship is in distress on the open sea, the AMVER system can locate nearby merchant vessels that can render assistance. At any one time, there are about 2,000 ships at sea, and reports on 1,000 to 1,500 come in every day where operators read the messages and enter the data. Today, part of the job has been automated by a natural language system. This system is able to read and completely understand about 80% of the incoming messages and understand most parts of the remaining 20%. Today, all interpretations produced by this system are checked by human operators. But even with this, the message backlog has been reduced by more than a factor of 10, and the productivity of the watch has improved by 25%. Seen another way, the system, including software development and 2 list machines, paid for itself in 14 months. What made this application possible is the narrowness of the domain. The messages are routine, concerned only with ship movements. They can refer to ports, ship names and call signs, headings, positions, speeds, times and dates, whether there's a doctor on board, and so on. But there won't be references to cargo or fuel or last night's soccer match. Because of the narrowness of the domain, current natural language technology can be used to decode most of the messages. Another message reader from Cognitive Systems, called ATRANS, is running in a bank in Manhattan. It also works on a very narrow domain, telex messages for money transfers from one bank to another. Because of the high volume of these messages, now and especially in the future, automation is highly desirable. The accounting and consulting firm Arthur Andersen has built another narrow domain text understanding system. It reads financial statements for the SEC. Although similar, there is considerable variation in corporate financial statements, both in how the information is reported and how entries are labeled. The financial statement analyzer accommodates those differences and then uses the information it's collected to calculate certain indices that are meant to reflect the health of the company. So we've seen that we're able to build text understanding systems that work well in narrow domain applications. But how many of these narrow domains are there? Cognitive Systems, the developer of 2 of these products, told us that they think there are many. Purchase orders, law enforcement, banking transactions, military communications, situations in which the range of things to talk about is limited, but in which people express themselves in a variety of different ways. And I can't help thinking about how a few years ago we were asking the same question about expert systems. Today, we see lots of applications while the list continues to grow. I suspect that although the growth will probably be slower since we don't have the same range of tools for building text understanding systems as for expert systems, we'll see a lot of applications for text understanding. In addition to expert systems, what are the other technologies that are paying off? We've been hearing about natural language. Is there anything else?
Well, I think one of the things has been, if you think of it as a fall, I mean, I'm not even really a card-carrying member of the AI community, I don't think. I've never really
You get to go on enough panels, you get a card.
Yeah, I guess I got a card by now.
Send them a card.
But
a green card, not a native born.
But I think the reason I'm here is I had something to do with development of object-oriented programming technologies, which are used very heavily in AI, many AI systems, but are came out of the simulation regimes of the 1960s, like Simula. So the idea that you have to, that if in the knowledge lies the power, as Ed likes to say, then the representation systems that you have and the ability of the representation to represent itself can give you tremendous amplifications of your effort. They're like new architectures. It's very hard to build a Romanesque cathedral the size of a Gothic one because the stresses tend to bring the roof down. And so these different architectures that in some sense have nothing to do with cognition or nothing that we know of to do with cognition are still tremendously powerful. I think an example there is that Apple does most of its systems building using object-oriented techniques. You could call that a way of using AI, but we don't call it that. We just think of it as it makes a big difference to the size of the final system, the integrity of the system, and how long it took to build the thing. And I think lots of other people, I know several companies that started out using a system like Key for doing expert systems, found that Key, because of its object-oriented nature, was also quite useful in simply doing production programming, and especially quick prototyping. And often they would start off prototyping just using the object-oriented stuff and then find that there are ways of using rules or vice versa. But I think this notion of there being large frameworks in which to build these programs, which are still too large, leads to these offshoots that I think of.
The rule-based representation is the one used by almost all of the new entrants to the expert system arena. They'll pick up a rule-based tool, they'll employ backward chaining, forward chaining on rules. That technology is something like 10 years old or more, and it has moved into widespread use. What those people should be aware of is that there is the more powerful allied technology which relies on complex descriptions of objects and worlds that can be used as a basis for inference. So in their enthusiasm to enter the field through rule-based programming, do not ignore that other aspect of the field, because the payoff is richer on the other side. Rules tend to be action-oriented or conclusion-oriented. They used to be called situation-action rules. But a lot of what you want to tell a machine, you don't want necessarily to be action-oriented. You just want to have it sit there, described, being ready to be used in some kind of an inference process.
Another thing that's come out more and more is the need to have the knowledge accessible to and manipulatable by the program. And if then rules give you one early superficial way that the knowledge can be used by the program, but very soon you begin to either want rules that reason about the rules, or you want the terms in the rules defined in terms of other knowledge structures that interrelate to each other, and so forth. And gradually you get to want more and more knowledge about the knowledge that you have in the system, and pretty soon the rules become a relatively small part of the system, tying together the bulk of the knowledge, which, as Ed has said, is largely non-procedural.
Now, why is it that you want all that knowledge about the knowledge?
Because unless you have an incredibly narrow, well, unless you have an adequately narrow task, you can't tell ahead of time exactly how you're going to need to use the knowledge. You can't tell exactly what pieces of knowledge you're going to need about each object.
How do you think that the people in the audience ought to consider these new programming techniques?
Well, I think on both the Apple Macintosh and the IBM PC, there are a variety of systems that they can learn most things. There's a good small talk on both machines. There are a variety of expert system shells. There are a variety of prologues. I think all of these techniques can be experimented with in a pretty comprehensive manner. The larger systems that run on workstations are not all that different, except in their size and capacity. So I would just advise people to go out and try some of these systems and experiment for a while and get an idea of what the new genre of programming are.
There are an awful lot of people out there who have been programming in COBOL and Fortran and more recently in C for quite some time. Do you think they'll be persuaded?
Most people that have who've had a success in anything will be persuaded that the new tool is good. So I think one of the ways of getting something positive out of it is to pick a situation where the new thing can really help you. In object-oriented programming, almost anything that has to do with something that's like simulation modeling or graphical design, a whole variety of things usually work out more successfully. So I think that picking the problem helps a lot, but I think for the more general techniques like object-oriented programming and inferencing, there's a wide, I think the whole program here is that there are a wide variety of new things that have been made possible. And my experience is that on the desktop personal computers that the people can experiment with these new techniques quite easily now.
Within the context of the PL1 COBOL and Fortran programmers, we're in the process of adding rules-based and inferencing capability to PL1, and we will do that to COBOL and Fortran.
Why not? You know, PL1's got everything else in it.
So you'll eventually be, that I think will be an easy transition for essentially the MIS program. I won't give us the full set of capabilities that one has, but you certainly will have that as a starting step for someone to learn.
But I think for the group of COBOL, Fortran, C programmers you're talking about, they should pay attention to the keyword phrases object-oriented programming and perhaps frame-based semantic nets, and go read about it, go take courses at their local community college or wherever they can about those concepts, and do the appropriate experimentation using the systems that Alan mentioned, particularly Smalltalk.
This would be in addition to rule-based programming.
I guess I should mention that...
I'm not talking about rule-based programming. I'm talking about object-oriented programming. The significant steps in the technology there relate to modularity of the work you're doing in software design, clarity of what you've gotten after you finish, and just the ease of programming it in the first place. There's really an order of magnitude effect there with object-oriented programming, and it's not widely known. The other thing I would, word of advice, is that if people have not been exposed to what the AI community, the research community, and now the applications community calls a good programming environment, they should get exposed to that at least once, and then they will become simply addicts. Most COBOL programmers, most Fortran programmers have not been exposed to a modern programming environment, and it's a spectacular productivity enhancer.
Yeah, exactly.
In many ways dominates the language that you use.